that you can test out on your MariaDB installations or MySQL installed. So select star from account where account ID is 591, and we just plop the explain command on top of it. So what this does is it generates the entire plan, it generates the query, it gets you, it understands the number of results that it would get. Short of actually showing you the data, it would actually show you this table. Right. So this table essentially says that this is the plan that this is actually following in order to execute this particular query. So we can see that for underneath table, it says that, you know what, I'm going to use the account table. That is obvious. We are going to look at the account table. Now underneath possible keys, since it is MySQL, it actually created indexes for the primary key. So it says that, you know what, I have the primary key as a possible index that we can use. And you can see that the key that is being used, and it says that the primary key is being used, the primary key index is being used to actually access the data. You can have also see other information like key length and stuff like that. But note that it also gives you the number of rows that is going to be generated. So essentially this explain command also tells you that this particular query would generate one row, right? Okay. So this explain command is really useful, and you would be using this command for your homework as well to figure out what indexes are best to be used, and essentially figure out if a database is actually using an index that is designed by you. So for example, let's take some other examples. Let's say that select star from account where account ID is A000. Well, there is no account ID with the account ID A000. Right? So when we say explain this, MySQL gives you this output. That is, again, table type now is null. It says impossible where noticed when reading constant tables. So this means that since it has an index, MySQL is being smart about it. MySQL is essentially saying that, you know what, I checked the indexes, I looked up the index values, and there are no possible values for A000, and that is why I'm just going to point you to a null table that has nothing, because this is not going to generate any rows whatsoever. So MySQL Planner and MariaDB planners are quite smart like that, right? Let's look at the previous query that we talked about. So select star from account where balance is greater than 3000. We know that there is no index for balance here, and we see that. And if you want to explain this, we see that your database says we are going to use that account table, but underneath possible keys, you now see that it is null. It says that, you know what, I do not have any indexes for this particular query. So it is not using any particular key, and it is just doing a normal file scan. And it also says that it is going to retrieve 60 rows from that table. So essentially there is no index available for this column that is balance. And that is why it is not using any keys, right? And the explain command actually tells us that. Okay, so how do we create an index? Well, it is really simple. Essentially, create index with the index name IDX_balance on account with the parenthesis balance. That is all you need to do in order to create an index for a particular attribute, right? For that table. So this would actually create your B tree indexes for you. And this might take, as I said, this might take a long time for large enough tables. For example, yeah, the 10 billion rows that I was talking about, the database that I was working with, actually took about 45 minutes to generate this particular index. But once you're done, then you are able to use it, right? You can also create multi-column indexes as well. You just need to separate them and delimit them with commas, right? So balance, comma, I don't know, account, branch name or something like that, right? Okay. So are there any drawbacks to putting an index on, putting an index for a particular attribute? Well, if it's a bank, balances might not be the best attribute to create an index for. Account IDs, yes. If I remove and create a new account or remove an account, that is very rare. But if you can imagine that balances change all the time, right? Everyone would be depositing money in their account, retrieving or withdrawing amount from their account. And so that changes a lot. And that also means that we would need to update our indexes quite a lot. And that is where the drawback comes in. If something is being changed all the time, it might not be really useful to actually create an index because of that extra overhead that you can imagine that something that changes all the time. So that would mean that if it takes about 45 minutes to create an index, it would take 45 minutes every time some update is being done to that account table, right? So we need to make sure that we choose our attributes for indexes carefully and essentially then use those particular attributes. Okay, so now let's say that either way we still created our index using this particular index command, that is create index idx underscore balance on account balance. And let's say that now we run the query, that is select star from account where balance is greater than equals to 3000. So if we want to essentially explain this particular query, we see something very neat about this. So what is going on here? So it says that, okay, possible keys are index balance, but it is not using the key for the index balance. It is still returning 60 rows, but it says that key used is null. Can someone tell me why? Any guesses as to why your database, even though there is an index for balance, your database is not using this particular index to compute this query? Any ideas? You can be wrong, you can just make a guess. Why do you think, if you were the database, imagine yourself as a database, you have an index, but you're not using it. What would be the reason behind not using an index? Are we lost completely as to what is going on? Long, David, Dennis, Divyasri, Dylan, Edgar. Why? So we have this, we had created this. Exactly, right? So it is easy enough to calculate without an index. Exactly, Cameron, you're correct. So even though we have this index that we had created, so that means that it has created this B tree, and essentially it has those mechanisms to get this data faster. And we just did that using create index IDX balance on account. Even though we have that, we see that the number of rows that it is reading is just 60. And so that means that these rows, these 60 rows can easily fit into a single block, right? So instead of actually uh, using the index, since our account table is so small, it feels that linearly scanning the data and just reading that entire table into memory and then just reading, getting you those 60 rows is much faster. The main reason behind this is our account table is quite small. Now, if we had our account table that is very large in the order of billions, then it might have possibly thought of using it. But this is a situation where it does not use it. And this is where, pardon me, and this is where your planner comes in. Your planner has this possible key that is for the IDX balance. Your planner has this possible key, but it has seen that it has made some estimates on the costs, and it is saying that, you know what, even with that key, I'm not going to use it because the other plan, that is to just read the entire table and just using a file scan to get me those 60 rows, it ends up being much faster. And that is why it ends up not using the key itself. Does that make sense? So does Cameron's answer make sense to you guys? Yes, no, something? Only one yes, two yeses. I can live with that, I guess. Okay. So finally, so this was so let's wrap this part up. So essentially you can see that so oh yeah, I have one other thing that I had to mention about this. So you can see that we had created an index, and imagine that it was a large database that required like an hour to create that index. And now that you have created that index, now we say that explain this query to me and tell me if you are using this index or not. So you spend an hour creating an index for a particular column, and then you see that um, exactly. So then you see that your index is not being used, right? So you created an index for an hour, you wasted that time, and now your database is not even using that index. And that is something that you would need to go through whenever you're designing indexes or choosing indexes. So you would choose an index, spend an hour creating that index, and then check whether the queries are actually using your designed index. Now if it is not using those indexes, you would need to just delete that index. How would we do that? Drop index idx balance, right? So drop index idx balance and then recreate another index from some other attribute or some other group of attributes, and then essentially test out your queries again. Creating those indexes would again take an hour, and then you would test out those queries again. Is the index that I have created useful or not? If an index is not useful, we will never want to have that index on record, because whenever we have indexes, whenever we make changes to our table, those indexes need to be updated again, right? So we really do not want unused indexes um, just hither and thither, right? We would want indexes that even though they take some time to be recomputed, even then um, executing the queries end up being much faster compared to not having those indexes in the first place, right? Okay. This is something that you will be able to play around with in the next. So to wrap up, so one other thing that we need to keep in mind is if we have large keys, so for example, varchar for the branch names or the usernames or the addresses, if we have large keys, they would seriously degrade your performance, because large keys often mean that there are fewer ways of comparing the results and having multiple branches from a particular node. Large keys usually end up creating deeper trees. And we really do not want deeper trees, because that would mean that the deeper the tree, the deeper the number of levels, that many, we would need to make that many comparisons. And the end goal of creating an index is to reduce the number of comparisons required, right? So essentially, we would want to use as short a key